1.7 is on inequalities, specifically linear and absolute value. So most of this is not new information. It should not be anything that's difficult. What we do have to remember in this class, though, is that anytime you would normally use an open or a closed circle, we're going to use a parenthesis or a bracket. So remember that parentheses are used to show an open interval. So if it would normally be an open circle, like a less than or a greater than, we're going to use a parenthesis on our number line and in our interval notation. If we have a less than or equal to or a greater than or equal to, then it's a closed circle, is what we have learned in the past. So we're going to use a bracket. A bracket is what we use in interval notation to say that this point is included. We're going to do the same thing with our graphing on a number line. All right, so to solve these, you're just solving an equation. There's nothing difficult happening. You're trying to get x by itself. Remember, you got to show all of the steps, though. So show that you add 5 to both sides. Show that you divide by 7 on both sides. We get x is greater than 3. All right, so they want us to solve it. You've done that. They want us to graph it on a number line and then write our answer in interval and set notation. I'm going to do interval notation every time, set notation occasionally. You don't have to do set notation on a test, but they may ask you for it in Math Excel. All right, so on a number line, I'm just going to center around 3 and let's show that we know what numbers are around 3. And then again, normally this would be an open circle, but we're going to do a parenthesis and we're going to go towards bigger numbers. So I'll do my parenthesis this way and shade towards the numbers that are bigger than 3. And then your interval notation basically looks like that. It's a parenthesis starting at 3, go to infinity. Infinity always gets a parenthesis because you can't be infinity. All right, and then set notation is really just what you got as your answer. You just put the fancy set of x's such that, and then your answer, and then close your little brackets, your braces. All right, so number 2. You can distribute this if you want, but you could just divide by, subtract the 5. I was a step ahead of myself. Subtract 5. Remember, this is negative 3. And then we're going to divide that negative 3. And then here's the thing you have to remember. If you multiply or divide by a negative, your inequality symbol flips because you're switching to the other side of the number line where numbers are going in the other direction. All right, so then subtract 2. All right, so we get x is less than or equal to negative 3. So on a number line, we are going to have a bracket at negative 3, and we're going to go towards smaller numbers. So make sure it's clearly a bracket and shade towards smaller numbers. So interval notation would be negative infinity to negative 3 with a bracket that tells everybody that negative 3 is part of the answer. Over here, positive 3 was not. You could get as close to 3 as you wanted, but you couldn't actually be 3. Here, you can be negative 3. That is one of the answers. All right, and then again, set notation is just putting the fancy stuff around your answer. All right, number 3. Let's see, we'll go ahead and do this. We'll subtract 5x and add the none. You can do all of that at one time. They accept that at Tech. You just have to show that it's being done. And then you also have to make sure that you say you divide by negative 1. So this flips and we get negative 12. So we're going to have a parenthesis this time. And it's greater than, so shade towards bigger numbers. So then interval notation says start as close to negative 12 as you want and go bigger. And set notation just puts the fancy stuff around your answer. All right, number 3. I could divide by 2 here, but when I do that, I create a fraction, so I'm not. In this case, I'm going to actually distribute. So 2x plus 8 less than or equal to 2x plus 3. subtract 2x, and we get 8 is less than or equal to 3. So remember, when your variables disappear, you're either going to get infinite solutions or no solutions, and it's whether it's true or not. So 8 is less than 3. That is false. So this would be a no solution for the empty set. All right, so compound inequalities is when we put two inequalities together. They can be joined by the word and, meaning they both have to be true, or they can be joined by the word or, meaning one or the other has to be true. All right, so for an and inequality, a lot of times they're going to write it like this. So instead of giving you two separate ones, they're just going to give you one with 3 parts. All right, so we're going to work on solving some with the 3 parts, the and inequalities that are all strung together. And then we'll do some absolute value where we'll be able to see what the ors look like. All right, so when you have one that looks like this, the goal is to get x by itself in the middle. So subtract 1 in all 3 places. And then divide by 2 in all 3 places. All right, and then we still want a number line that we graph on. And we're going to say, literally, we go from -2 to +2. That's what this is saying. X is trapped between -2 and +2. Make sure those look like parentheses and then shade in between. So then your interval notation would be -2 to +2. And then again, set notation, you're just going to put the fancy around. All right, so that's the last time I'm writing set notation. All right, so for number 6, we're going to add 5 to all 3 pieces. And then divide by 3 in all 3 places. So then on a number line, we're going to be trapped between 2 and 6. We get a bracket at 2 and a parenthesis at 6. Remember, brackets are when we have equal to's, parentheses when there's not an equal to. Interval notation is going to be bracket 2 to 6 parenthesis. And then set notation would look like this. All right, so for absolute value, we have to remember what absolute value means. So this is saying the distance from 0 is less than 3 units. So if you think on a number line, the distance from 0 being less than 3 units would mean somewhere between -3 and 3. So we would have all of these numbers. So x would fall between -3 and 3. Or I could write that as x is greater than -3 and x is less than +3. All right, if we have a greater than, I want numbers that are more than 3 units away from 0. So that means we would have to be farther away than 3 and farther away than -3. So we would be -infinity to -3, and we would be 3 to infinity. Anytime you have two that you need to unite, you use that union symbol to unite them. All right, so that would be that x is less than -3 or x is greater than +3. So you see over here it's an and because we're trapped in between. I can be both. Over here I have to be one or the other. I can't be in 2 places at one time. So it's an or. So what you really need to pick up on and remember is that if it's less than, it's an and. Greater than is an or. All right, so to solve these, we're going to do it the same way that we did absolute value equations. You're going to have to write 2. The first one, nothing changes. You just lose the absolute value bars. The second time, you flip the symbol and make it a negative. You flip the symbol because you made it a negative. You're going to the other side of the number line. And because it started out less than, it's an and. Writing that word is a whole point on your test, so make sure that you don't skip that. All right, so we end up with x is less than 9 and x is greater than negative 5. So on a number line, we can do negative 5 here, 9 here. I'm not writing all those numbers. I can do a little zigzag and say I skipped some. It would be nice to put a few numbers around the ones you're actually using. All right, and then we're going to have a parenthesis at 9 and go smaller, and a parenthesis at negative 5 and go bigger. So since it's an and, we should end up trapped in between two numbers. So interval notation is just negative 5, comma 9 with parentheses on both ends. And then your set notation, you would say x such that, and then you just have to say that x is going to fall between negative 5 and 9. All right, so number 8, we're going to add 5. We're going to divide by 2. And then we can split. So x plus 3 is greater than or equal to 7. Since it's greater, we're going to have an or. And then x plus 3 is less than or equal to negative 7. So subtract your 3. So x is greater than or equal to 4. X is less than or equal to negative 10. So on a number line, you have negative 10, we have 4. We want a bracket at 4 and greater than. We want a bracket at 10 and less than, at negative 10, sorry, and less than. So then your interval notation would be negative infinity to negative 10, bracket u, because we're skipping some numbers, and then 4 to infinity. All right, and then set notation, again, this is the last time I'm going to write this. Set notation would be x such that, and then since we have two separate things, we can just say less than or equal to negative 10 or greater than or equal to 4. All right. Let me move these down a little. Okay, maybe I shouldn't have done that because this is more complicated than it needs to be. There it goes. Okay. All right, so here we're going to subtract 20. Divide by negative 3. Which is going to flip our symbol and make this 13. So 5x minus 2 is less than 13, and because it's less than, 5x minus 2 is greater than negative 13. All right, so then we're going to add 2. And divide by 5. So x is less than 3. Here, when we add 2 and divide by 5, we get that x is greater than negative 11/5. But I'm going to try to put that on a number line. I'm going to go ahead and call that negative 2 and 1/5, just so I can find it on a number line. Okay, so -2, -3, so -2 and a fifth would be roughly here. And then -1, 0, 1, 2, 3, 4. We would have another parenthesis at 3, and then we shade in between. So interval notation would be -2 and a fifth, or -11 fifths, comma, 3, with parentheses on both ends. All right, number 2. This says the absolute value of something is less than -3. Now, the fact that absolute value has to be positive, and we're saying it's less than a negative, means this is no solution, because all of the numbers less than -3 are negative, and absolute value can't be negative. If that had said that that is greater than -3, then you could have solved it and come up with some solutions, because some of the numbers greater than -3 are positive. Actually, most of the numbers greater than -3 are positive. But if you ever get absolute value less than a negative number, you can stop and say no solution. All right, so these, they want us to write them as a single interval. So the easiest way to do that is to think about each one separately, and then how do I combine them? All right, so on a number line, I need the numbers 1, 5, and 8. And it says we want everything up to 5. And then I want everything from 1 to 8. This is U, is union. It means or. This this symbol is an intersection. And you can read that like an and. All right, so here we're uniting these. So anything that's shaded goes. So if I combine those, then I'm going to go everywhere from -infinity all the way to 8. Like all of this was shaded, so that is my solution. All right, number 12. You just have the number 2 and the number 4. We want to be 2 and bigger. We want to be 4 and bigger. I was going to do that in a different color. All right, so again, that U symbol means we're going to unite them. So anything shaded is fair game. So we're going to go from 2 to infinity. All right, 13. All right, those are all the numbers in play. So let's see, we go -4 to 0. And they also want us to do -2 to 1. Put those up brackets. All right, this is an intersection. It's an and. It only occurs where they overlap. So this little bit in the middle where the colors overlap is our answer. So we're only going to go from -2 to 0. All right, the last thing is being able to write an absolute value given the solution set. All right, so if you think about what this means on a number line, this is saying the answer to the problem are all of the numbers between -3 and 3. So what I need to know is what's the middle. So in this case, it's 0. So the distance from 0 just means absolute value of some number. And we need that because we are trapped in between. We need that to be less than 3 units. All right, this one, we have everything going on out here and everything going on out here. That's what they have us shading. The center between those, the middle point is 0. So again, the distance from 0, or the absolute value of x. And now we're going to be greater than or equal to 3 units from 0. Because we have the brackets, we need the equal to, and because we're going away from that central point, we need a greater than. All right, so a little more complicated when the numbers don't center on 0. So we got 7, 8, 9, 10, 11, 12, 13, 14, 15. So what's the middle? So 1, 2, 3, 4, 1, 2, 3, 4. So the middle is right here at 11. We're saying we want everything here to here, but we need to know what the middle number is. And we also need to know how far is that from either end. And so in this case, it's 4. All right, so we're going to say that we want the distance from 11 to be less than, because it's trapped, equal to, because of the brackets, 4, that number that they are away from, that central number. All right, so the number in the absolute value is the central number, what's in the middle of the two numbers, and then the number on the end that you're less than or greater than is going to be how far they are from the middle. All right, so trying another one. We got 3, and we want to be out here. We've got 11, we want to be out here. So we need to know the middle between 3 and 11. So 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8. So I made this one 4 away again. So the middle number is 7. And the distance between them is 4. So we would say x minus 7, the distance from 7. And this time it's going to be greater than with no equal to because of the parentheses. And greater than because it's going out. And 4 again is how far away from 7 we want to be. All right, so again, whatever falls in the middle of those numbers goes here, and how far that is from the end goes on the end. All right, that is all for 1.7. Make sure you ask questions if you have them.